everyone. Today I'd like to talk about Swift macros. So if you never heard of Swift macros before, don't worry. I will explain everything, I hope. And if you are already familiar, I believe you will get know something useful or valuable from this presentation. So my goal is simple. Swift macros should be less magical for you, more predictable, and I believe you could use them in your daily Swift development. So, okay. A few years ago, I had the opportunity to work with other programming languages like JavaScript or Python, and I encountered there the creators. The creators, if someone worked with JavaScript, they attach additional behavior to class, to method, but don't modify its core implementation. And when Swift macros appeared in Swift approximately 2 years ago, I thought, wow, we have the creators in Swift. So key question is Swift macro. What actually is it? And are they the creators? And answer is they are something different, because there are key differences between Swift macros and the creators, which we could know from GS or JavaScript or Python. So I will show main differences. The first is that execution time. Swift macros work in compile time, and the creators in JavaScript or Python work in runtime. And purpose on Swift macro is a code generation, and as I said, purpose of the creators is modifying functions or classes. And Swift macros, they don't have any runtime cost, but the creators in JavaScript, they can be impacted in time. Syntax is very similar, except freestanding macro, but they are called with add. And usage context is also very similar, because we add both macros and the creators to structs, classes, functions, methods, and debugging. As far as I got in JavaScript, debugging could be tricky, but with macros we can debug. An year ago, when I researched this topic first time, there were some comments that Swift macros are very heavy to debug, and but it is possible. I think I will explain you how while writing your own macro. Okay, so now I will show you all macro roles. There are two types of macros. First, it's a freestanding macro, and another one is attached macros. Freestanding macro could generate some expression or declaration in code, but attached macro, they are interesting, because they could analyze and modify or add something to code where we have attach macro. So attach macro, we could, for example, add a new declaration or accessor, member attribute, member, or add conformance. I will show you the example of attached macro, especially member one and conformance one, and how to write this macro on your own. Okay, so let's start with Swift macro structure. First, we can't create a macro within a project. We have to create Swift package, and this package should require at last 3 files. A file with declarations. It looks like headers that we describe types macro and macro's name, and fields with macro expansions and plugin declaration. Fields with files with macro expansion, they are basically implementation of macro. And the last one, but not the less important, truly, it's a client file that we this client file is executed if we, for example, run this macro in Xcode. Okay, so let me show a Swift macro example. At the first sight, it looks a little bit difficult, but I will explain you what does it do. And first is that we retrieve argument from macro call, and that we fetch from node some string, and in the another step we build declaration extension, and you could spot some fragments of Swift code, but they are wrapped into syntax. And the first sight, it looks like what is syntax. It's a little bit crazy. It was my impression when I encountered this first time, but it isn't so complicated. I think I will explain basics, how to work with that. There exists another way to write macro. I don't recommend this, but if you practice yourself, you could return plain string. I found this macro on GitHub. So some guy who bragged that he wrote on macro on LinkedIn, but if you are this guy, so don't offend, don't be offended to me. But what is disadvantage? This plain text. We don't have any control what this macro generates, and unfortunately, Xcode doesn't collaborate with us very well, because if I will show in other slides that if you made a mistake with your macro, it shows some unknown error or no such file or directory. It was happening, at least Xcode 16, it improved in the latest updates, but I don't recommend this way. I believe I have explained to you why. Okay, but syntax, Swift syntax. All code you write in Swift could be shown as a syntax. So, for example, if you declare some variable or function, it's a declaration syntax. Of course, those big dots, they are protocols, and those small dots were examples of instances. There is a huge list, so I selected only a few ones to show you. But we could spot here, for example, if statement syntax. So if you wrote it, if in your code, it is on low level, represented as if statement syntax. If you use some binary operator, if it is represented as binary operator expression syntax, or if you put some type into array, it's array type syntax, and so forth. So every code we wrote in Swift, it would be represented in a syntax tree, and there's a cool website to get your syntax tree, Swift as the Explorer. So if you work with some structure in your macro, you could get a structure, get a syntax tree from struct, class, method, and so forth. And you should be able to check the syntax and write write an expansion. But while writing a macro, sometimes you need to know what is inside. What are you working with? How to, for example, find some field, method, property, and etc. So we could print declaration somewhere in text, of course, for the debugging, not debugging, development purposes. And we could also debug macro, and I could share that debugging macro is possible if you test macro. And I think it's one of the main reasons why to test your macros. And I will show you tests in the end of this presentation, because now I'd like to show you my first macro, what I wrote for this presentation purposes is auto ID macro, and this a little more brighted line is expanded line. Maybe it's not well visible, but this declaration of ID was added by macro. And this macro first checks does ID property exist in object, and if it already exists, it returns error that this macro cannot be executed because object already contains ID field. If this error wouldn't be handled, compilator would add ID property to this another ID property to this struct, and compilator would return the error that ID variable or constant ID is declared multiple times. So let's talk about implementation this macro. First, as I told you, we check does property not exist in the type, and I went through this syntax tree, what I obtained from Swift as Explorer, and I'm check that ID property exists, and if is it true, I diagnose an error that property is already declared. And if check is false, we build declaration extension, and it just first we create variable syntax, and we return the declaration syntax wrapped variable syntax wrapped into declaration syntax. Of course, this example isn't the best, in my opinion, because not all errors are handled here, because those errors from this maybe this try, they aren't handled, but I spotted it too late. Okay, another example, identifiable macro extension. So it works at the same similarly to the previous macro, but this time it check struct or class it works with, and it adds extension conformance to protocol in the identifiable. And if name of property is declared here, identifier, it adds computed var with returning property named like we wrote in invoking. But there is also handling an error that if you call macro with wrong property name, it doesn't found this property. It of course extension part was executed because it extended some struct, but it didn't add computed var, and it returned error that variable called couldn't find variable called wrong property name. And now I will show an implementation. So first, of course, like in the previous example, we get argument from mark call and check does ID property exist like in the previous example, but this time additionally we retrieve its type syntax, because in computed var we have declared what type we return. And after that we have to handle fallback if property name is given and type syntax is not determined. For example, that we didn't find variable and constant called identifier. So I handled this error. And finally, we built declaration extension. And here, firstly, I wrapped expression syntax into variable syntax, and finally, I wrapped it into expression syntax into variable syntax, and finally in extension syntax, and that's it. Okay. Last one, not last one slide, but the most important, or maybe no, if you wrote macro, is write a test. Here we could see tests that we check expansion does match or not, and testing macro have advantage. Testing macro have advantage because we are able to set breakpoints inside macro and see what is happening inside. I'm not sure I told it before, but if you want to see the syntax tree as Swift Explorer shows, we have to print the bug description. Okay. Swift macro disadvantages. On version 16 of Xcode, I encountered error that failed to receive result from plugin, and it was of course mistake inside macro, but it was very heavy to get what went wrong. But it improved in Xcode 26. Another disadvantage is limited documentation ecosystem. They are relatively new. They appeared in Swift 5.9. And of course, they have impact into compilation time. Okay, but except writing macros, you could use someone else macros. There is a great list made by Krzysztof Zabłocki, Swift macros. If you If you want, you could enter into QR code. In my opinion, the most valuable in the moment macros, they are macros which could serve into dependency injection or networking. I am experienced in using a Swift blade into the dependency injection in and Papyrus for networking. And I prepared a simple example how, for example, is using Papyrus. We just add macros. It looks like JavaScript decorators. When I worked with Node.js code a few years ago, we handled requests by decorators which look like the same like this. And now, if you attached Papyrus or other networking macro, Swift macro, or if you wrote your own one, you could handle your calls in that way. Okay, so I believe I told you everything what I know about Swift macro. It's a joke. Thank you for listening. If you want to, if you aren't satisfied with those examples of macros I've shown you, you could research my macro via this QR code. They are available on GitHub. So that's it.
Elaborate what other functionality does this context allow? So you use it for like diagnosing, giving like messages, but what else is possible?
Actually, you could use it for everything what you want. Well, for example, if you if you want to log, right, some simple logger, and you could write, for example, macro which adds calls logger to function or to methods, whatever you want. I think it makes that code looks a little bit better, maybe more simple, because code which is in macro is added in compilation, and actually my purpose of this macro is that you don't care about what is inside a macro, what is a main paradox, in my opinion, but actually my purpose is short, and main purpose of macros to make shorter production code, because, for example, if you attach some logger or some dependency injection, you just call this macro, and it modifies your declaration of class structure function, whatever you want. And I think that's it. It's my purpose. If you, as is practical use, in my current project, I use it for networking and dependency injection. But we will see what will be in future. I believe I answered your question. Okay, maybe question to public. Okay, if you listen to me, so the first question: how to get syntax tree in Xcode? Yes, you're right. And another question, a little bit more difficult: what kind of syntax is variable name? Okay, I think it's I could acknowledge this question, this answer. Okay, so that's it.